Welcome to Chapter 16, Lecture 2. In Lecture 1 of Chapter 16, we illustrated a competitive general equilibrium. And we did so using two markets, and we found a set of prices for each market, which resulted in the simultaneous equilibrium of those two markets. And we call that a competitive general equilibrium. And the key there was that these two markets were linked by virtue of the fact that consumers treated these goods as complements, and therefore the price in each market was also relevant to the price in the other market. Now, what we did was we showed the existence of those two prices. And as I said at the time, that even though we just did it for two markets, the existence of a set of prices that generate a competitive general equilibrium has been proven for an economy consisting of any number of markets, producing any number of goods. So we can be confident that a perfectly competitive economy can achieve a general equilibrium. What we want to do now is to analyze the characteristics of that equilibrium. In particular, we want to look at the efficiency aspects of a competitive general equilibrium. And we are going to do so over the next two lectures. Today, I just want to focus on the consumption side or exchange side of the economy, and then we'll bring production in on the last lecture, and we'll tie it all together into a big bundle and discuss its welfare characteristics. So what we're going to do today is we're going to put together what I call a 2x2x2 model. We're going to look at an economy that consists of two consumers who consume two goods that are produced by two sectors, each sector producing one of the two goods. So by having a 2x2x2 model, we can draw it, since we can draw in two dimensions. But everything that we do in two dimensions, as I say, is relevant for n dimensions. So it's not particularly as limiting as you would think. The only problem that we have is with, when we only have two consumers or, two producers, it's hard to think of it as being competitive, but we can make some assumptions that force it to behave as if it were a competitive economy. So let me share my screen here. So as I was saying, what we're going to do is a 2x2x2 model. So our model will have two consumers, and they're going to have some very creative names. They're going to be consumer 1 and 2. And they're going to consume two goods, which also creatively will be X and Y. And these goods are going to be produced by two firms or two sectors, however we want to think about it. Sector producing X does so with this production technology. It employs labor and capital. And the sector that produces Y does so with this production technology that employs labor and capital. Now, to make this thing sort of function like a perfectly competitive economy, we assume that both of these production functions produce with constant returns of scale. Therefore, there will be zero profits. So we at least get that aspect of a competitive economy. And we're also going to assume that our individuals, when they engage in a priced market transaction, will take prices as given. Although today we're going to look at individuals who themselves simply make exchanges without prices before we add prices. Now, as I said today, we want to just work with the consumption or exchange side of the economy. And what we're going to use in order to illustrate what an exchange equilibrium looks like and analyze its properties is we're going to use something that's called an Edgeworth exchange box. And let me put this together real quickly here. I've got consumer one's tastes and preferences. And I'm going to assume that these are well-behaved tastes and preferences. And so consumer one has an indifference map illustrating those preferences that is convex to the origin, as always. So here's consumer one's tastes and preferences drawn out for us. And same holds for consumer two. I'll do consumer two in red, so we got red and black here. So for consumer two is going to consume X and Y, and also has some tastes and preferences over the consumption bundles containing X and Y. So this is all pretty standard. We have two consumers, consumer one, consumer two, both of whom have well-behaved tastes and preferences. Now, what we're going to suppose here is that since we have no production in our economy, we're going to suppose that each consumer has an initial endowment, of X and Y. So each consumer, where the consumer got it, we're not too concerned about. We're just saying the consumer has some quantity of X and Y to begin. So consumer one has, we'll say, this amount of X. I'm going to put a bar over the top to indicate that that's this consumer's endowment, and this amount of Y. And consumer two also enjoys an endowment. So consumer two has this amount of X and this amount of Y. Now what that means is for the economy, the total endowment of X is, well, it's going to be X bar, and that will be the sum of our two individuals' endowments. So our economy has a fixed amount of X available for these two consumers to share in consumption. And for Y, it's going to be Y bar is going to be the sum of our two individuals' endowments of Y. So our economy has a fixed amount of X and a fixed amount of Y available for these two consumers to share between themselves. Now, each comes to the market with an initial endowment, but what we're going to allow is for these two consumers to make exchanges so that they can trade X for Y or Y for X, and their actual consumption bundle then can deviate from their initial endowment by virtue of the trades that they've made, all right? So what I want to do is I want to rewrite these consumers' tastes and preferences, taking into account the fact that we have a finite amount of X and a finite amount of Y available. And so for consumer one, back to consumer one's tastes and preferences over X and Y, what I'm going to look at is I'm going to say, okay, our economy only has X bar and Y bar available. So I'm not going to worry about my consumers' tastes and preferences beyond what is actually a feasible consumption area or space here. So I'm only going to worry about my consumer one's tastes and preferences as they relate to possible consumption bundles that are limited by the initial endowment of our economy. And the same holds for consumer two. I'm going to do the same for consumer two. I'm going to say, well, consumer two, in no scenario can consume more X than the economy has, nor more Y than the economy has. So I'm going to do exactly as I did before with consumer one. I'm only going to worry about consumer two's tastes and preferences as they apply to what's available here. So there's consumer two's tastes and preferences. I can't let my indentures cross. Oh, so now note that these are both these rectangles over which we've illustrated the tastes and preferences are equal size. They're the same rectangle, only just different tastes and preferences. And what I want to do now is I want to create my Edgeworth box. And how I'm going to do that is I'm going to take consumer one's tastes and preferences, and I'm just going to look at those tastes and preferences over this rectangle of dimensions X bar, Y bar. Here's consumer one's origin. And then I'm going to, and I can draw them in here. Let me draw a few in here. I've got, here's an indifference curve here, and here, and here, etc. It's convex to one's origin. And then I'm going to take the indifference map here for two, and I'm going to take just this rectangle here, and I'm going to flip it over. I'm going to flip it over so that the origin for person two moves to this corner here, and the x-axis now goes in this direction, and the y-axis will go in that direction after I flip it over. So I'm going to take this flipped over preference map for person two, and I'm going to put the origin, rather than at this corner, I'm going to flip it up to this corner. And as I was saying now, this is going to have dimensions X bar, Y bar. It's the same area as, ones. In fact, we're sharing now, we're illustrating the consumption possibilities for our two individuals. And I'm going to have a whole series of indifference curves here too for person two. So that insofar as this goes, since this is the origin for person two, as I go to the southwest, the utility for person two is increasing. So going in that direction, I'm going to higher and higher utility curves because the origin now is up here at the top. And for person one, these indifference curves for person one, as I go to the northeast, utility for person one is increasing. Now the key thing about my box here is that we are always going to be at exactly one point in the box. So I come back and draw this thing. Again, this is X bar and Y bar. And I have my other person two's origin up here. And so as I said, I'm going to be looking at X2 as we go in that direction, and Y2 as we go in that direction. And down here, I'm looking at X1 as I go in that direction, and Y1 as I go in that direction. So since these are both consumption goods, we know that they're all going to be consumed because both of our consumers want to maximize their consumption of both X and Y. So when I pick a point, I just close my eyes and I pick a point in the box. Let me call this point A. That represents an allocation of our economy's endowment between these two individuals. In other words, that means that person 1 at point A has that much X and that much Y, and person 2 at that point then has the balance. So person 2 has this much X and this much Y. And so that point in the box then fully allocates our economy's endowment of X and Y between these two individuals. And as I say, we are always at one point in the box because the individuals are sharing these fixed quantities. Now, suppose that we made a trade so that individual 1 made a trade with individual 2 by trading some X away. So individual 1 gives up some X. Let me make that black. Individual 1 gives up some X in exchange for some Y. And that gets us to point B. But if individual 1 gives up some X in exchange for some Y, there's only 2 people trading. That means that the individual 2 is going to be getting more X. So individual 2 is going to be getting more X and giving up some Y. Ick. So individual 2 now ends up with more X, but less Y. Here at point B. But if individual 2 has more X, that means individual 1 must have less X, but more Y. So that's what a trade would look like. One person's gain in quantity is exactly the other's decrease in quantity, and each person's decrease in quantity is the other person's increase in quantity. Now, they're always going to trade Y for X. No one's going to make a trade that would make them worse off, and we're assuming these individuals are utility maximizers. So trades will take place whenever there is a benefit to at least one of the 2 consumers without any detriment or loss of utility to the other consumer. Ideally, we would think in the best of circumstances, both individuals can benefit from a trade. If so, they will make the trade. A mutually beneficial trade will clearly be something that both would want to engage in. Now, as I say, this again, making this point, whenever we move from one point to another point in the box, it implies one individual giving something up in exchange for the other good, and the other individual gaining some of the one good and losing some of the other good. They're always offsetting movements that we have when we move around inside the box. Now, let me come back to my box one more time here. Let me draw it again. And my dimensions are always the same, even though they don't look like it. Now let's come back here to point A. Now we know that an individual has an indifference curve that goes through every point in consumption space. So let me find the indifference curve for person 1 that goes through this point A, right there. Okay, so here's point A. And there's the indifference curve for person 1 that goes through that point. And the same holds true for person 2. So for person 2, again, here's the indifference curve. It's convex to person 2's origin. And it looks like that. It kind of looks like that. Now, first thing to notice here is that at, what am I doing? What a dumb drawing that was. Let me try this again. I have to draw this through point A. So, all right, so there's the indifference curve for 2 that goes through point A. Now, the first thing to notice here is that at point A, the marginal rate of substitution for person 2 is greater than the marginal rate of substitution for person 1. I want to do that the other way, make my notation the other way around. We'll make this marginal rate of substitution for person 2 as a subscript at point A is greater than the marginal rate of substitution for person 1 at point A. And you can see that because here's the slope of the indifference curve for 1 at point A, and here's the slope of the indifference curve for 2 at point A. And it's quite a bit steeper for 2 than it is for 1. So the marginal rate of substitution for 2 is greater than the marginal rate of substitution for person 1. Well, remember what the marginal rate of substitution said. The marginal rate of substitution was the most Y the consumer would forego in exchange for an additional unit of X. The most Y. The other way to think about it was the least amount of Y the individual would accept to forego a unit of X. All right? Once again, the marginal rate of substitution was the most Y an individual would forego in exchange for an additional unit of X, or the least amount of Y the individual would accept to forego a unit of X. Now, you can see right here that individual 2's willingness to give up Y for X is greater than person 1's minimum willingness to accept Y for X. So there's room for trade here. Suppose that the MRS for person 2 is equal to 6. The MRS for person 1 at A is equal to 2. That means that person 2 would trade up to 6 units of Y for an additional X. Whereas person 1 would accept no less than 2 units of Y for an additional unit of X. So if, for example, person 1 were to give person 2 4 units of Y, would be willing to give up to 6, but 4 would seem like a pretty good deal maybe. So person 2 offers 4 units of Y for a unit of X. Person 1 would be just indifferent between the trade if she got only 2 Ys for an X and they're being offered 4. So person 1 would be happy to accept 4 units of Y for an X, and person 2 would be happy to pay 4 units of Y for an X. They would both be better off. And as a consequence of making that trade, let's say we move up to here, right? So person 2 gives up 4 units of Y. So that means person 2 has 4 fewer units of Y. But by the same token, that means person 1 now has 4 more units of Y. In exchange, person 2 gets an X in exchange. So person 1 has 1 fewer unit of X, but that means then that person 2 has 1 additional unit of X. So let me make that black. Right, so what one person trades away, the other person gets. What one person gets, the other person must trade away. So when we made this trade at 4 to 1, it was mutually beneficial in terms of utility. So we moved to a point up here where now 1 is on a higher indifference curve and 2 is on a higher indifference curve. And this, we call this, let's say, point B. So they're both better off through this exchange, and they have moved each to a higher indifference curve. Well, as you can see the way I've drawn it, the MRSs are still not equal. And in fact, there are all of these possible consumption bundles that would be available to them to trade to that would make at least one of them better off without making the other worse off. Anything, that's not on, but between these two indifference curves that go through point B would actually be a bundle that makes both better off. Anything on the indifference curve here would be a bundle that could make one better off without making the other worse off if we were on one of the two indifference curves between point B and this intersection of the indifference curves. So since the MRS is still not equal at point B, there's still room for trade. Well, exchange will always take place whenever the marginal rates of substitution for 1 is not equal to the marginal rate of substitution for 2. Always. Because one's willingness to pay exceeds the other's willingness to accept. Now, if I were to come back to my box here and take a point, at the other side here, and say, rather than make my point A down in the lower right-hand part of the box, suppose I made my point A up here, my starting point right here, and exactly as before now, in this case, there's the indifference curve of 1 that goes through that point. Here's the indifference curve of 2 that goes through that point. And there are all these trades in here that would all make each better off. So will they trade? Yes, they will. And who's going to trade and how? Well, here's the marginal rate of substitution. That's the slope of the indifference curve for 2 at that point. Didn't quite hit a tangency. And here's the slope of the indifference curve for 1 at that point. And as you can see in this case, now it's the exact opposite. The marginal rate of substitution for person 1 at point A is greater than the marginal rate of substitution for person 2 at point A. So now it's 1 who is willing to pay more Y for X than would be the minimum amount that 2 would demand. So now we're going to trade in this direction. we're going to find trades where the exchange rate of Y for X is somewhere between these marginal rates of substitution. So, suppose in this case, the marginal rate of substitution for 1 at point A was 3. The marginal rate of substitution for 2 at point A was 1. Well, in this particular case, 1 would be willing to pay up to 3 Ys. 2 would be willing to accept as little as 1 Y for an X. So they're going to find some middle ground there. Suppose it's 1 gives up 2 Ys for an X. So we move to this point. So that means then that 1 goes down 2 Ys, but gets an X, and person 2 now is going to have to give up an X. So that's minus 1, but 2 gains 2 Ys. And they'll continue to trade as long as their marginal rates of substitution aren't equal. Well, where's it all going to stop? It's all going to stop when their marginal rates of substitution then, through exchange, become equal. So what's that going to look like? We started here at point A. Here's the indifference curve for 1. Here's the indifference curve for 2 that goes through point A. They're going to trade, and they're going to trade somewhere into this area, that's between these two indifference curves. And let's just suppose, it depends on their negotiating skills. It's not obvious how we're going to end up here, but let's suppose that we end up at this point right here, where the indifference curves are just tangent so right here at point, let's call this point, let's give it a new name. How about point D? Here at point D, at D, the marginal rate of substitution for person 1 is exactly equal to the marginal rate of substitution for person 2. Because their indifference curves are just tangent, they have exactly the same slopes. Now notice, even though I flip, 2's axes around, the slopes are still going to be the same. It's just, it's now it's just going to be the negative of Y over. It's going to have, it's going to be, still delta Y over delta X, and it's going to be negative. But whereas if, delta Y is positive and delta X is negative for person 1, then delta Y is negative and delta X is positive for person 2, but the ratio is exactly the same and it's negative. So the slopes of these indifference curves can be read from either origin, just like we would read it from the origin for person 1. And so now at point D, there are no more beneficial trades. So if, for example, here, MRS for 1 is equal to 2, and that's the same as MRS for 2 at point D, then that says that their willingness to give up is exactly equal to their minimum amount they would demand. The maximum willingness to give up is equal to the minimum amount they would demand. Therefore, there are no more mutually beneficial trades, nor any trades that are beneficial to one without hurting the other. So we say at point D that we've reached a point of efficiency in exchange. Point D, we say, is efficient. In that, there are no more beneficial trades, mutually beneficial trades. But what this also means is there is no other allocation of our endowment that can make one consumer better off without making the other worse off. So you can see at point D here we are. Any other allocation, anything that would make two better off going in this direction must necessarily make one worse off. And anything that would make one better off must necessarily move closer to two's origin or make two worse off. So this for us is a definition of efficiency. And we call this Pareto efficiency. Pareto efficiency. After the economist Vilfredo Pareto. Pareto efficiency in exchange occurs when there is no exchange, for that matter, allocation of the goods that can make one person, one consumer, better off without making the other worse off. Now, when I come back here and look at this, there could have been any number of other possible points they could have traded to that would have also been Pareto efficient. So for example, they could have maybe traded to this point here, point E. And at point E, here's person one's, let me get this down. Person one's indifference curve going through point E. And here's person two's indifference curve going through point E. And it's just going to be tangent. But point E is also a point where the marginal rates of substitution are equal. And at point E, both consumers are better off than they were off at point A. So they may be willing to go to point E. It looks to me like one would prefer E to D and two would prefer D to E, but that's not terribly relevant for our argument here. The simple fact is that they've made trades, they've negotiated exchanges that have gotten them to a point where both their marginal rates of substitution are equal. And once they get to that point, they can't find any more trades that can make at least one of them better off without making the other worse off. So in that case, they have reached an equilibrium in their exchange. They've reached a point where they're no longer going to be trading. So it's an equilibrium, and it's also a Pareto efficient equilibrium. Now, there could have been point E, there could have been all kinds of points in here that would have been between these initial, let me make this a blue line, all kinds of points that would represent a point of tangency between indifference curves. And all of those points from this point on the initial indifference curve for 2, and this point on the initial indifference curve for 1, both of them going through point A, and there are all these points that occur at tangencies between indifference curves. And every point on this, except for these 2 points on the indifference curves, represents an allocation that is mutually beneficial to our 2 consumers than the allocation at point A, and therefore could be a point to which they trade. Now, if we were to get to a point on the indifference curves, that simply says that one of the 2 is very shrewd and captures all the gains from trade. So although, you know, say we worked our way to this point right here, call it F, it's on one's initial indifference curve. One would be no worse off at that point, and 2 would, of course, be better off. But there's a tangency right there. 2 would be better off, so 2 would have extracted the maximum amount available from gains in trade. We assume that no consumer would willingly ever make a trade starting from point A that would make them worse off than they are at point A. So we have to be at a point where they are at least no worse off, and the indifference curves are tangent, which is to say one of the allocations that's on that line between the 2 indifference curves and reflecting all the points of tangency. Now, no matter where we start, we're going to get to the same result. So, you know, if I could start, say, here, well, give me a second. I could start, say, at this point right here. Let's make it down here. This point right here. And again, you know, here's the indifference curve for 1 going through that point. And here's the indifference curve for 2 going through that point. Don't want to do that, did I? And so once again, you know, we don't have equality between the marginal rates of substitution. So they're going to trade somewhere up in this lens that's created between these 2 indifference curves where they intersect. Now, we're going to find that there might be a value in here, say a point. If this is our point A, well, there's going to be some point B in there that corresponds to a Pareto efficient allocation. Again, characterized by tangency between the indifference curves or equality between the marginal rates of substitution. And as before, there could be any number of such points that would go between these 2 indifference curves. So I would again have, say, any point on this indifference curve on the 2's indifference curve, all the way down to 1's indifference curve, the 2 indifference curves going through point A, that could be possible Pareto efficient allocations. Now, since that exists everywhere, what we assume here is then that, point of fact, if we were to identify what are all the possible exchange equilibria that could occur, well, the whole box, again, let me just draw a whole series of indifference curves for 2. The whole box is dense with indifference curves. And that's for 2. And then it's dense with indifference curves for 1. And so I might think of then a series of indifference curves for 1. If I identify in each case, for each indifference curve for 2, I find the indifference curve for 1 that is just tangent to it. And I would have a whole series now of indifference curves for both 1 and 2 that are just tangent. And each of these points of tangency would represent a Pareto efficient allocation of X and Y between these 2 individuals, of our endowment of X and Y between these 2 individuals. And the key here, you know, is to recognize that these individuals, through their exchange, are always going to want to make a trade if there's a mutually beneficial trade available. So I think about these points existing everywhere because there are indifference curves everywhere. And so if I connect all the points that represent a point of tangency between these indifference curves, I get this line that goes through the box that we call a contract curve. And a contract curve is the locus of all points in the box where the marginal rate of substitution for 1 is equal to the marginal rate of substitution for 2. So these are all the Pareto efficient allocations available to this economy. So when I draw my box, and I think about my individual's initial allocations. So I said that my individual 1's initial allocation of X was X bar 2, and of Y, Y bar 2. And for person 1, the same. Person 2 had this much X and this much Y in his or her initial endowment. This establishes our starting point. Each individual arrives in our market with their own endowment. And the sum of their endowments then establishes the dimensions of our box. Now, if I put in here the contract curve, I know once we have the individual tastes and preferences, then I get this contract curve going through the box. I can say this. I can say that since my individuals are off, with their initial endowments, they're off the contract curve. That means they are not at an allocation that's Pareto efficient. And if the allocation is not Pareto efficient, then there are trades that can make at least one of the two individuals better off without making the other worse off. So the individuals will engage in trade. Well, where are they going to go? I don't really know. I just know this. I can restrict where they're going to go. Remember, this is our point A. So insofar as person 1 is concerned, 1 would only make trades that do not push 1 below that initial indifference curve, would never make a trade that was utility decreasing. And here's 2's indifference curve through that point. So 2, remember this is point A again. So 2 would never make a trade that would push it below that indifference curve. Where they're going to go, they're going to trade as long as their marginal rates of substitution are equal. And they're going to end up then at some point on the contract curve between those two initial utility indifference curves. All right, between those two indifference curves, between these intersection points here. Okay. So they're going to trade always to the contract curve. And all of these points then are Pareto efficient. These points here that aren't between there are also Pareto efficient, but they're not points that would arise through voluntary exchange starting at point A. Now, let's suppose that instead of that initial endowment, we had, say, initial endowment consisting of this much for person 1 and this much Y for person 1. And so that means then that the initial endowment for 2 was, this much, X bar 2, and for person 2, Y bar 2 there. Same deal. If we identify now the indifference curves through that point, this different endowment, goes through that point, then what do I end up with? I end up with the same argument, basically, that they're going to trade whenever they're off the contract curve, they're going to trade to the contract curve. So they would trade down in this direction. So regardless of what the initial endowments are, as long as they add up to our X bar, Y bar for the economy as a whole, our box stays the same. And we can start from any point in this box and identify that segment of the contract curve, which would be a possible set of allocations to which they'll trade. And they'll always end up with a Pareto efficient allocation between them. Now, think about this Pareto efficiency. Does not consider equity or fairness. You know, look, think about this. Suppose that we gave all X and all Y to person 2. So here's person 2's indifference curve to that point. So 2 has everything. 1 has nothing. Doesn't seem very fair, but it's Pareto efficient, because the only way we could make 1 better off, starting at this point right here at 1's origin, would be to take some X or some Y or some of both away from person 2 to try and improve 1's lot in life here. And that would necessarily make 2 worse off because more is better. So 2 would be made worse off is the only possibility for making 1 better off, starting down here at this origin point for 1. Not fair, but it's efficient. Same holds up here. If we gave everything to 1 and nothing to 2, then we would be at this point, and this would be 1's indifference curve. The only way we could make 2 better off would be to take something away from person 1, which would necessarily make 1 worse off. So 2 itself is also, this point up here at the corner of 2's origin is also Pareto efficient. And same with every point along this contract curve. They are all Pareto efficient. Now, let's think about our box here one more time and think about the contract curve. So here's the origin for 1, and here's the origin for 2. Here's our contract curve. And what we're saying is that all these points on the contract curve represent a Pareto efficient allocation in the sense that these are all the points where, let me just put some indifference curves in here. These are all points where there's a tangency between the indifference curves. And to make those tangencies happen, I gotta move things around here. So here's that tangency. It's supposed to be a tangency. Here's a tangency. Here's a tangency. Getting closer. And here's a tangency. Practice, practice, practice. They say, how do you get to Carnegie Hall? Practice, practice, practice. All right, so and here's a tangency. Now, what I can do is I can look and I can see, well, what is the utility associated with each of these indifference curves? So suppose for person 2 here, utility on this curve is equal to 40. And utility on this curve, further from the origin, is equal to 70. And utility on this curve is equal to 100. And utility on this curve is equal to 140. utility on this curve is equal to 190, and utility on this curve is equal to 220, because we have a utility associated, constant utility along each of those indifference curves. And for person 1, the same holds. So suppose on this indifference curve, U1 is 10, U2 on this indifference curve is 25, U2 on this indifference curve is 40, this indifference curve, 60, this indifference curve, 100, and this indifference curve, 150. So I look at this point right here and I say, okay, what is it? And what I want to do now is I want to plot the utility that's available to each at every point on the contract curve. Remember, these are Pareto efficient points. So there's no way to maximize, there's no way to increase one person's utility without reducing the other's utility. So right at this first point here, utility for person 2 is 220. At this point right there, I read that off that indifference curve, and utility for person 1 is 10. So there's a point on what I'm going to call my Pareto frontier. That is to say, these are the maximum utilities that can be gotten because, this is, let me phrase it this way, that 220 would be the maximum utility for person 2 if we were to give person 1 a utility of 10. So in that sense, it's maximal. I can't increase 2's utility past 220 without reducing 1's utility. And that would violate this notion of Pareto efficiency, which is implicit on our contract curve. If I were to look at this point, this is associated here with a level of U2 of 190. U2 is 190 and U1 is 25. So there's another point on my Pareto frontier. Since I'm mapping the utilities from the contract curve, these are all Pareto efficient points. Going to this point here, what do I get? I've got utility here is 140. Is 140, and this utility there is what? 40. So there's another point. And I just keep this up. I come to this point. What do we got? We've got utility here is 100 for 2, person 2. And that's associated with the level of utility for person 1 of 60. So here's a point. And let's just go lastly at this point right here. U2 is 40. U1 is 150. We have to get out here further, aren't we? Let's make this 150. Clean up my drawing a little bit. And so, if I did the same for every single point on my contract curve, I looked at what the levels of utility for both persons 1 and 2 were at that point on the contract curve. What I would do is I would be drawing a utility frontier where every point, where every pair on that frontier of, person 1 and U2 is efficient in that we cannot increase one person's utility without decreasing the others. So these are all the pairs of efficient, Pareto efficient utilities. Now, if we were to think about a point off the curve, suppose I were to pick a point right here. And, it's on person one's indifference curve there. And suppose person two's indifference curve through that point were to look like that. Now note, person two's indifference curve through that point, even though one's utility is, what do we say one's utility is there? We're saying that one's utility is 10. Two's utility, however, through that point is on a lower indifference curve. So in point of fact, two's utility is something less than 120. So it lies inside my frontier. So all these other points in my box, every point is associated with a pair of utilities. And every single one of those points that are not on the contract curve would yield a pair of person one and person two's utility that is interior. So these are all points off of the contract curve. Everything inside, everything on the frontier are points of utility taken from the contract curve. And everything that's outside here is not attainable. We can't get to any of those combinations of utility because of our fixed endowment that fixed the size of our Edgeworth box. So this is my notion of efficiency. This is my notion of efficiency, this idea of Pareto efficiency. And it's what we want to work with for our economy. What we want to talk about is there an allocation that can make one person better off without making the other worse off? And if there is such an allocation, then the economy, with the same amount, finite resources, can improve the welfare of at least one person without hurting the other, then the economy should reallocate. That initial allocation is not efficient. But once we get to an allocation where we cannot make one person better off without making the other worse off, then we argue that our economy has achieved a Pareto efficient allocation. These lights are way too bright. All right, so we'll stop there and we'll go on with production side on the next lecture. Bye-bye.